Imagine you're starting a 10 horsepower motor on a conveyor line, or bringing a large HVAC compressor online in a commercial building. These systems draw high inrush current, produce electrical noise, and require reliable, repeatable switching. Your PLC or control system can't directly handle that kind of load. That's where contactors come in. A contactor is a high-current electrically controlled mechanical switch used to turn large electrical loads on and off. Unlike standard control relays, which are typically limited to 10 amps or less and often use solid-state internal components, contactors can handle hundreds of amps and are engineered specifically for heavy-duty industrial switching. Industrial motors, solenoids, and transformers generate large inductive electrical loads and voltage spikes. Connecting them directly to a PLC output would risk serious damage. Instead, a contactor provides isolation and allows a low-voltage control signal, often 24 VDC, to switch a three-phase power circuit safely and reliably. A contactor contains three main components: a coil or electromagnet, which creates a magnetic field when energized, an armature, which is pulled down by the magnetic field, and power contacts, the heavy-duty conductive elements that open or close the load circuit. Applying voltage to the coil pulls the armature down, closing the power contacts and energizing the load. Remove the voltage and a spring forces the contacts open, interrupting the circuit. This design supports high current switching, effective arc management, and long mechanical life. Contactors are used anywhere high power loads require controlled, safe, and repetitive switching, like motor starters, HVAC systems, heating circuits, lighting banks, and automated machinery. Their construction allows them to operate in harsh environments, manage electrical arcs, and perform thousands of cycles. Electrical loads aren't all the same, and contactors are rated accordingly. Resistive loads, like heaters and incandescent lamps, draw steady, predictable current, making them easier to switch. Inductive loads, such as motors and transformers, store energy in magnetic fields, creating high inrush currents during startup and voltage spikes during shutdown. These stresses create more wear on switching contacts, so contactors carry different ratings: AC1 for resistive loads, and lower rated categories like AC3 or AC4 for inductive loads, where both mechanical and electrical demands are higher. Relays and contactors share the same electromagnetic principle, but relays are intended for low power control circuits. Contactors, on the other hand, are horsepower rated and designed for high current, high voltage switching, making them the correct choice for motors and other large loads. Some are even designed to allow easy assembly with additional components that monitor motor health or enable safe direction control. So whether you're starting a large motor or controlling industrial heating elements, the contactor is the reliable interface between your control system and high-power equipment. To learn more about contactors or to purchase one for your application, visit us today at AutomationDirect.com, the #1 value in automation. Click here to learn more about our contactors. Click here for more videos.